We're going to dive into the world of mathematics and demystify radicals. We will look at how roots, radicals, and rational exponents all connect to each other, and by the end of this presentation, you'll see exactly how straightforward they really are. Let's start with the basics. What actually is a radical? Put simply, a radical is just an expression that involves a root, like square root or a cube root. If you know how exponents work, radicals are just the exact inverse operation. They undo powers. When you look at a radical expression, there are three key parts to know. First is the radical symbol itself. Second is the radicand, which is simply the number or variable trapped inside the symbol. And the third is the index. That's the small number sitting outside on the ledge that tells you exactly which route you are taking. If you don't see a number there, it's always an implied index of 2, meaning a standard square root. The core rule. The fundamental property of radicals is shown right here on the slide. When we say the nth root of x equals r, it simply means that if you raise r to the power of n, you get x back. In other words, we are looking for a base number that when multiplied by itself n times gives us our starting value. To see this in action, let's look at the two quick examples. The square root of 49 is 7 because 7 times 7 equals 49. Similarly, the cube root of 8 is 2 because multiplying 2 by itself 3 times gives us exactly 8. Rational exponents. Now let's look at a massive shortcut in algebra, writing radicals as fractions. Radicals and fractional exponents are actually two sides on the same coin. The mathematical rule tells us that the nth root of x to the power of m can be rewritten seamlessly as x to the power of m over n. A great way to memorize this is that the power stays on top as the numerator and the root index digs underground to bottom as the denominator. So if you ever see the cube root of x squared, you can immediately rewrite it cleanly as x to the 2/3 power. Golden rules. When it comes to simplifying radicals, there are two golden rules you must keep in your back pocket: the product rule and the quotient rule. The product rule tells us that if two numbers are multiplying inside a radical, you can split them up into two separate radicals or lock them together if they are separate. The quotient rule does the exact same thing for division. If you have a radical over an entire fraction, you can split it into a separate radical for the top numerator and the bottom denominator to make simplifying much easier. Rationalizing. This brings us to a very important rule of mathematical etiquette called rationalizing the denominator. In formal math, leaving a radical sign in the bottom of a fraction is considered unsimplified, kind of like forgetting to reduce 2/4 down to 1/2. To fix this, we multiply both the top and bottom of the fraction by the radical we want to get rid of, because the radical multiplied by itself clears the root. The denominator becomes clean rational number, as you can see in the example where 5 over the square root of 3 simplifies beautifully to 5 root 3 over 3. To wrap everything up, let's look at our main takeaways. Remember, radicals simply undo exponents. Every radical can be rewritten as a fractional exponent, and always make sure to tidy your final answers by rationalizing your denominators. Thank you for your time. Does anyone have any questions before we walk through a few examples together? Let's start with question 1. Simplify the square root of 75. To simplify radical, our goal is to find the largest perfect square that divides into the radicand. Looking at 75, we know that 25 fits exactly 3 times. So using our product rule, we can split root 75 into root 25 into 3. Now we break them apart into two separate radicals: root 25 into root 3. Since 25 is a perfect square, the square root of 25 simplifies perfectly into the whole number 5. The root 3 cannot be simplified any further, so it stays exactly as it is. Bringing it all together, our simplified answer, the final simplified answer we have for question number 1 is 5 root 3. Now let's tackle the question number 2. convert to a radical and simplify. A very simple and easy way on how to do this question is, we know that 16 is basically 4 into 4, right? So this can be written as 4 to the power 2 whole square, 3 to the power 4. Now, you can make 3 to the power 4 small, right? If you multiply 2 into 3 by 4, we know that 4 can be divided with 2, right? So we have 2 left and only 2 here. So we'll have 4 to the power 3 by 2. Now 2 can be written as 4 can be written as 2 to the power 2, 3 to the power 2, right? And then what can be done is 2 into 3 by 2, right? And then you can cut the 2. We have left 2 to the power 3, which is equal to 8. So the second answer would be 8. We're done with this session. And to sum up this entire session, the sources I've used is Larson R and Boswell L, Khan Academy, and OpenStax. Thank you so much.